Well, hi everybody. In this version of Ecademy, we're going to be talking about scientific notation, which for 7th and 8th graders is a really important concept used in both science and math classes. So let's get started. Scientific notation at its most base sense is composed of a number times 10 to another number. Scientific notation is used to write really big or really small numbers in a more concise way. For example, the distance from the Earth to the Sun is about 93 million miles. So if we write that number out in standard notation or decimal notation, 93 million is a very long and very big number. Obviously there's numbers much bigger than that and numbers much smaller than that. A scientist would look at this number and say, that's way too many zeros. We want to find a shorter and more concise way to write that number. So to do that, we look at what number can we pull out of here that's between 1 and 10. A hint is to start here at the beginning and move your decimal spot over 1, 9.3. In general, you can stop after you see the repeating zeros. So my first number would be 9.3. Now this number that starts at the beginning, 9.3, has to be between 1 and 10. Second step we do is we write out times 10. So 9.3 times 10. The reason we do that is because now we're going to count how many spots it takes from the decimal we put right there after the 9.3 to get to the end of our number. So we're going to count to the right here and swoop as we go. 1, 2, 3, 4, 5, 6, 7 spots to the end. 7 spots now becomes our power. So 9.3 times 10 to the 7th is equivalent to 93 million. Scientific notation, decimal notation. Scientific notation also works on. So if I make up a number that's really small, let's say 0.000000138. First thing we want to do is look at this really small number and pick out a number between 1 and 10. A little tricky here. So we look at the end and we look at these 3 digits here. What's a number I could pick out that would be between 1 and 10? Well, 138 is too big. 13.8 is too big. 1.38, that works. Again, the number has to be between 1 and 10. So I'd pick that out and I'd pull down my 1.38. That's going to be my leading number. 1.38 times 10. Now for the swooping. So I take my decimal point and stick it right up there at my 1.38, same as right here. And I count out to the beginning this time, going backwards. 1, 2, 3, 4, 5, 6, 7 spots to the beginning. Now if I put a positive 7 up here, that'd be like the first example, where we'd start here at 1.838 and we go 7 spots this way. That's not what's happening. We're starting here and we're going to the left. Since we're moving the decimal to the left, we say -7. In fact, anytime you see a negative exponent up here, it means the decimal spot has been moved to the left that many times, 7 times, and we've got a very, very small number in our hands. Next, let's take a look at a couple examples of scientific notation. This first example says the national debt of the U.S. is $970 billion. Write this in scientific notation. Well, the first thing we need to do is write that in decimal notation, or the real number for 970 billion. So 970 billion, there's 970. That's 970,000. 970 million. 970 billion. So there's my big number in decimal notation. And following the format we talked about earlier, we need to find a number here out of this whole 970 billion that's between 1 and 10. This is a very big number, so I can start here at the beginning and go right there. That would make that 9.7. So I'll drop down my 9.7 times 10. And now I count how many times till I get to the end of 970 billion. So I'll put my decimal point back up here in the in the decimal notation number and count to the end. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 times to the end. 9.7 times 10 to the 11th power, and this is now in scientific notation. That would be my final answer. Look at the second example. It says the weight of a substance is 0.00089 milligrams. Write this in scientific notation. So let's get in a little closer here and look at that number. We want to look at a really small number now. Here's our decimal out here. We want to come to the beginning and pick out a number between 1 and 10. So let's get rid of that. So the number that we see in here has got to be 8.9. 1 over there, 8.9 is right between 1 and 10. So there's my decimal. I would drop down 8.9 times 10. Now it's time to count back to the beginning of that number and see how many spots it takes to get there. 1, 2, 3, 4, 5 times. Now again, if I put a 5 up here, that means 8.9 times 10 to the 5th is a very big number. Since I counted from the decimal and counted left, I need a negative at that. So 8.9 times 10 to the negative 5th power. And that is a little overview on scientific notation. Feel free to watch this video as many times as you need to get this down. Thank you for listening.